5D optical data glass for permanently recording digital data using a femtosecond laser writing process. The memory crystal is capable of storing up to 360 terabytes worth of data for billions of years. The concept was experimentally demonstrated in 2013. Hitachi and Microsoft have researched and developed 5D optical storage techniques. The 5 dimensions consist of the size, orientation and the 3-dimensional position of the nanostructures. The concept is the bulk storing of data optically in non-photosensitive transparent materials such as fused quartz, which is renowned for its high chemical stability and resistance. Writing into it using a femtosecond laser was first proposed and demonstrated in 1996. The storage media consists of fused quartz where the spatial dimensions, intensity, polarization, and wavelength is used to modulate data. By introducing gold or silver nanoparticles embedded in the material, then plasmonic properties can be exploited. Up to 18 layers have been tested using optimized parameters with a light pulse energy of 0.2 microjoules, 5.6 times 10⁻14 kilowatt-hours, a duration of 600 fs, and a repetition rate of 500 kHz. Assuming a 100% efficient laser, that is 1 watt-hour, 3.6 kilojoules, of energy consumption for a maximum half a megabits of data storage. For 1000 megabits of storage that adds up to 2 kilowatt-hours, 7.2 megajoules. Testing the durability using accelerated aging measurement shows that the decay time of the nanogratings is 3 times 1020 plus or minus 1 years at room temperature, 30 degrees Celsius, 86 degrees Fahrenheit. At an elevated temperature of 189 degrees Celsius, 372 degrees Fahrenheit, the extrapolated decay time is comparable to the age of the universe, 13.8 times 109 years. By recording data with a numerical aperture objective of 1.49, a wavelength of 250 to 350 nanometers, 9.8 times 10⁻6 to 1.38 times 10⁻5 in, a capacity of 360 terabytes can be achieved. The format has a novel method of storing data called 5-dimensional. This is more for marketing purposes since the device has 3 physical dimensions and no exotic higher dimensional properties. The fractal/holographic nature of its data storage is also purely 3-dimensional. According to the University of Southampton, the 5-dimensional discs have tiny patterns printed on 3 layers within the disc. Depending on the angle they are viewed from, these patterns can look completely different. This may sound like science fiction, but it's basically a really fancy optical illusion. In this case, the 5 dimensions inside of the discs are the size and orientation in relation to the 3-dimensional position of the nanostructures. The concept of being 5-dimensional means that one disc has several different images depending on the angle that one views it from, and the magnification of the microscope used to view it. Basically, each disc has multiple layers of micro and macro level images. It can be read with a combination of an optical microscope and a polarizer.